Broadcast is now starting. All attendees are in listen-only mode.
Hey everyone, welcome. We're just going to wait a few more minutes for more people in case they're running late, but I plan to start in a few minutes. Thanks. Hey everyone, just in case more people have joined, just waiting to allow those who are coming in late to join, but we will be starting in just another minute or so. Okay, well, I think I'm going to kick things off now. Welcome. Good evening to those of you in Europe. Good day or midday to those of you in the US. And if you're over in Asia, it's probably extremely early. I'm Jason Yee. I work with Datadog as a technical evangelist, but wanted to give a quick shout out to the Codemotion organizers for putting this on. So thanks to all of their fine work for getting this webinar set up and continuing to contact speakers like myself to help share information so that we can all get better at the jobs that we're doing, both technically and non-technically. So I love this quote from Henry Ford, the American automobile maker. who revolutionized how we build automobiles. But he said the only real mistake is the one from which we learn nothing. Henry Ford was all about moving quickly and experimenting, and realized that mistakes do happen, but they were excellent opportunities for learning. A little bit about who I am, though. I'm Jason Yee. Like I said, I'm a technical evangelist with Datadog. I like to say that that boils down to docs and talks. So I do technical documentation for our product, and I present webinars, and I go to conferences and I speak, and I do a bunch of other interesting things with Datadog. For example, I have written and maintain our Heroku integration. If in case you have a question, feel free to post that through the GoToWebinar console. It should be there on your right. But if you have any questions after and you feel like reaching out, I'm GetBisect on Twitter. A little bit more about me. I travel around quite a bit. I'm currently a nomad. I don't live any particular place, but I'm joining you today from Charlotte, North Carolina in the States. And then I do love whiskey, so I like to, when I travel, find interesting regional whiskeys. A little bit about Datadog. Datadog is at Datadog HQ on Twitter, in case you feel like following or reaching out that way. We are a SaaS-based monitoring platform. That means that people install our agent or configure integrations, for example, with AWS, Google Cloud, Azure, and they send their metrics to us, and we help them provide the dashboards and the insights and the alerts that they need. To give you an idea of the scale of what we handle trillions of points of data every day. And we are hiring. So if you're on this call and you're interested in helping to provide tools to other developers, tools to other operations engineers, if you're interested in working with huge amounts of data at a very large scale, feel free to hit that link, jobs.datadoghq.com, or feel free to reach out to me later as well. Be happy to get you into a position where you're doing interesting, challenging work that excites you. Now, if you were to get a job at Datadog, aside from going through the regular onboarding and getting business cards made and getting your laptop set up, you would have access to our internal developer guide. And I love our guide because at the very top of it, we have this statement. And it's that the problems that we work on at Datadog are hard and don't often have obvious clean-cut solutions. So it's useful to cultivate your troubleshooting skills, no matter what role you work in. And I love this statement because I think it applies to not just our jobs within Datadog, but it applies to every single technical job that's out there. All of us are working on technical solutions, and as we've progressed in what kind of solutions we build into things like using microservices or using third-party services or APIs, the complicated systems that we work on become more complex, and it is much harder to solve problems than when we were setting up static HTML sites that were just being served from an Apache web server. So you have to cultivate your skills in order to figure out what's going wrong. Now, within the world of DevOps, this has led to a rise of what's called blameless postmortems, and perhaps many of you have heard of this. But blameless postmortems essentially espouses that we shouldn't blame people when things go wrong, because blame has a number of negative consequences. So if we step back from the blameless postmortems and talk about what DevOps is and why DevOps led to the rise of blameless postmortems, well, I like this definition from Damon Edwards and John Willis. They're two gentlemen who were some of the leaders of the DevOps movement. And a long time ago, at the very first DevOps days in North America, they coined this acronym CAMS to describe DevOps. And they said that it was a culture of collaboration and working together. It was a bit of automation. So using automation to not only increase the speed at which we can do things, but hopefully reduce errors as well. They said that there was metrics involved in DevOps. You have to be able to measure how well you're doing and have insight into where you can perform better. And then finally, you have to have the sharing, right? You have to not only use your metrics to understand your systems and understand your organizations, but share that information to keep teams aligned and moving together. When it comes to DevOps, it's really interesting that the culture is that first part of it. A lot of people jump immediately to automation. But when we think about automation and what we can do with it, it really isn't the automation. And I love to give the example of, for example, the Great Pyramids. The Great Pyramids are massive, and they're an incredible feat of engineering. And when we look at how they were made, it's very clear that there was no automation involved. The ancient Egyptians didn't use big cranes and bulldozers or power tools. They just used their hands and chisels, and they had a lot of people doing it. But really, that lot of people doing it was because they were all organized and they were working together. If we jump forward to today and we think of how we build things today, what construction looks like today, yes, we have automation. We have giant cranes like this that are hundreds of feet in the air. But we have to understand that all of that has to come with that culture bit, that collaboration, because no amount of automation would help us to align angles correctly. Or in the example of this crane, if there was no communication and collaboration, you could see that mistakes could easily be made, that this crane could suddenly start dropping large payloads in the wrong place or on top of people and having big accidents. So we understand that when it comes to DevOps, culture is key, and you have to have that culture first before we have the automation. And when we think about the tools that we use, it's important to keep that in mind, that Docker will not solve your problems, or continuous integration will not necessarily solve your problems if you don't have that culture in place first. Now, when it comes to postmortems, or how we analyze failures, well, the focus for blameless postmortems is often that culture bit and then the sharing bit, right? Because we want to analyze what we're doing, gather that information up and share it. So when it comes to blameless postmortems, we understand that the culture bit is very important, that we don't want to blame people when something goes wrong, because blame will inevitably lead them to not tell us what actually happened and won't build the cultures that we want. It won't build the culture of collaboration and working together. Now I could go on and on about blameless postmortems, but really here's a couple links, and I will share these slides later so you'll have easy access to them, or feel free to take a screenshot of your computer right now. But the first is by John Alspaugh, and he is really one of the four leaders in the blameless postmortems movement. That's a link to his original blog post about blameless postmortems. And the second is from a gentleman named Dave Zwiebach, who's written a lot about postmortems as well, and about the human side and how we account for humans in the mix. But culture and sharing are fantastic, and they're a huge part of DevOps. But when it comes to learning, and if we think of CAMs, well, what about the metrics side, the M in CAMs? Well, for a lot of people, this might be a good representation of how they feel about the metrics side of having a postmortem. It would require them to actually know that something went wrong. So at Datadog, we feel that it's extremely, extremely important that you have the data that you need. So we say that collecting data is cheap, and not having it when you need it can be expensive. So you should instrument all the things. Just to give you an idea of how expensive it is, the Aberdeen Research Group has a very well-quoted figure of how much money companies lose for an hour of downtime. And for medium-sized companies, that number is right around $300,000 or 250,000 euros per hour. And if you're a large company, they say that that number is right around $750,000 or $750,000, or about 600,000 euros per hour of downtime. So we understand that we really do need to collect metrics. But one of the problems and the reasons that people don't collect metrics, or don't collect the metrics that they actually need, is because they don't understand the good qualities of metrics and how to look for what the right metrics are, or what the right metrics are to be measuring. So let's talk about those four qualities of good metrics. And the first is that they have to be well understood. In short, everybody on your team has to not only understand what a metric means, but where that fits into their system. And there's this great great analogy of the blind men and the elephant. And the story goes that there are a group of blind men, and they're all touching an elephant and trying to describe what an elephant is. But because they're blind and they're only touching limited portions, one blind man reaches out and he grabs the tail. And he says, oh, the tail, this is thin, and it's long, and it feels like a snake. So the elephant must be like a snake. And another one reaches out and he grabs around the legs. He says, wow, this is big and thick and really sturdy. An elephant must be like a tree. And so they have all these different conceptions of what an elephant is. When it comes to metric, it's very similar. With metrics, we can't have separate ops teams and separate dev teams and all these different teams with their own metrics and monitoring solutions. We have to understand how all of our teams fit together in order to understand what the whole system looks like. So your metrics have to be well understood. You all have to be on the same page, and that might require having the same tool. Now, the second quality of good metrics that we need is that they have to have sufficient granularity. Now, the Winter Olympics just ended. I'm a big fan of the Netherlands, particularly because I like speed skating and they do so well. The thing that we understand about speed skating is that you have to have the right resolution, right? The right granularity when we're measuring the times for a race, particularly in the fast races. So these are some of the final times from the men's 500-meter speed skating event. Unfortunately, much to my disappointment, the Netherlands did not place, but we can see some of the times here. And we notice that between the first place, that gold medal finisher, and the second place, so between Norway and Korea there's only 1/100th of a second of difference. So we understand that for things like speed skating here or other sports, granularity matters. If we were measuring on whole seconds, well then all of these gentlemen would have won. There isn't that much difference, but we know that we have to measure down to the 100th of a second in order to figure out which one has won. And even at that, sometimes there still are ties. They could still get the same time down to the 100th of a second. When it comes to our metrics, we have to understand that granularity matters as well. If I take a look here at a simple CPU chart, I can see that on the top row, I have a spike in my CPU metrics, and it spikes at about 46.5%. And it happened at 2 p.m., 6 minutes and 16 seconds. But when it comes to our metrics, oftentimes we have roll-ups or we have aggregations. And so oftentimes those 1 second granularity will get merged into a 1 minute slice. And we have to understand that not only when we do that will we lose some information, but our information will change or it will become skewed. So if I look at that 1 minute roll-up, well, not only has that spike now not happened at 2 p.m., 6 minutes and 16 seconds, it happens at 2 p.m. and 6 minutes. So we lose that 16 seconds, but we also see that it gets averaged down. So it's no longer as high as it was. If I go all the way to a 5 minute aggregation, which some companies do, well, we see that again, the time has shifted all the way to 2 p.m. and 5 minutes. So if something were going wrong, we wouldn't know exactly where to look. We would be off by a whole minute and 16 seconds. But we also have the problem that when we've aggregated this, well, now that problem, that CPU spike, has been averaged away. There no longer is a spike. The third quality that we need for our metrics is that they have to be tagged and filterable. When we think about a metric point, often we think of these three attributes. A metric point or data point is a name, a what is it? What are we measuring? And it's a value. How much was it? And then it's a timestamp. When did it happen? And these things are very important, but one of the things that many people miss out on is that they need tags. You need to understand the where with your metrics, especially as we start to build systems that are starting to be geographically distributed, whether that's having a CDN with endpoints to try to get closer to our customers, or whether that's having availability zones so that we can have more reliable infrastructure. But when you have this tagging, it allows you to ask questions. You can now slice and dice your data. So you can start to ask useful questions like, what's the average throughput of my application Nginx per version that we've deployed? Or how many requests per second is my accounting application running on Postgres hosted in region US West 1 compared to US East 1 or compared to Western Europe 1? The fourth quality that we need for metrics in order to collect the right data is that they have to be long-lived. In short, we have to keep our data around long enough that we can understand the patterns and the trends. Now, when we take a look at the public cloud offerings that we have today, if we look at AWS CloudWatch, they keep things around for 15 months, but they do a roll-up to 1 hour granularity. And as we saw, granularity can be really important. As we can see here as well, Azure monitoring services will keep things for 90 days, but again, they do a roll-up to 1 day. Google Stackdriver, they only keep things around for 6 weeks, but they actually don't do any roll-ups. Their standard granularity is 1 minute. At Datadog, because we support all three of these, we have to take the longest version. So we've supported data retention up to 15 months. And then we support it at 1 second granularity. So we don't do any roll-up. So those are the 4 qualities of metrics that you really need to have. But let's talk about what types of metrics you ought to have and how to think of your metrics. And I like to group metrics into really 2 buckets, with events being sort of a third category. So the 2 types of metrics that you absolutely need are work metrics and resource metrics. And then we'll use events to later correlate those. Work metrics are things like throughput, success, errors, and performance. They're things that matter at a high level to the business. Now, I really like donuts. Donuts are, I feel like, a very great way to start the morning with a cup of coffee. But if I give you an example of a donut factory, my work metrics for a donut factory are going to be how many donuts are going through the line, how many donuts am I making at any given point. If I think of successes and errors, how many donuts are properly glazed versus how many donuts are improperly glazed and I have to just throw them away. They're not good to sell. Overall, it's my performance of how many donuts are being made. On the flip side, our resource metrics are the things that are there to support the making of the donuts, or in the case of technical systems, to support your work metrics for your technical systems. In the donut factory, this would be things like how much sugar do I have? How much flour do I have? Do I have enough butter? In the case of errors for the resources, do I have a bunch of salt because someone thought salt looked close enough to sugar, but it's the wrong thing? In short, for our systems, this boils down to really availability. Do we have enough of the things to support what our work metrics are? And then events. So events aren't actually metrics, but they're the things that give us context around what's going on in our systems. And so in this case, context could be things like National Donut Day. Are we out of donuts? Because even though we're producing enough, everybody's eating donuts. In the case of our events for our technical systems, this could be code changes, new deployments, scaling events, things like that. And you want to take both of these types of metrics and use them together. So when you have a technical issue, you want to start with those work metrics, those high-level things that matter to your business. And then you take the resources that support that, and you look at any sort of correlated events. So on a high level, your first work metric might be that customers cannot log in to your web application. Well, what's the resources behind your web application? Well, you need your web application needs to function. Perhaps it corresponds to an authentication service. Well, that authentication service is one of those resources. That becomes a work metric for somebody else, the service owner for the authentication service. That's their top level work metric. You can take a look at the resources. Well, what goes on behind the authentication service? Well, that probably requires some databases, for example, a user database. So you can take that resource metric, and that resource metric, a database running, becomes the work metric for your database team. Your database team needs to have servers in order to run a database, so that's their resource. And you can continue to drill down for each of your teams to find those correlating resource metrics that support the work metrics. And then you can take a look at the events that have caused them to change. Now, as we take all of this data that we're collecting, and if we're collecting the right data, and we're trying to drill down through that, one thing to note is when we're looking for problems, there is no singular root cause. When people say root cause to me, I always ask them, have you looked at a tree? Have you looked at a plant? They don't have single roots. They have branching roots. And when it comes to complex systems, we have to understand that as well. Even when it seems like there's one major technical issue, we have to understand there are always contributing factors around the people involved, around the technical systems, about how we build the systems that we do. Now, I do mention that there are those human elements, and those human elements are often the things that contribute to the technical issues that we have. So as we jump into how to run postmortems, well, one thing to notice with that human element is if you're still responding to an incident, it's not the time for postmortem. In the same way that if you were a police officer who showed up at the scene of a major auto accident or auto collision, you wouldn't try to figure out who was doing what and which way the cars were coming from as cars were driving by you and still colliding with each other and exploding everywhere. You have to wait for that to finish, resolve the issues around the accident, make the accident essentially stop so you can isolate it and analyze it. Now, as I mentioned, a police officer at the scene of an accident, well, that's a great way to start analyzing the data around the humans. So if we think of the data that we need to collect about who we should collect from, well, think of yourself as a police investigator. When we think of police investigators coming to the scene of a crime or an accident, who do they talk to? Well, first, they usually talk to the first responders, the other police or the firefighters or the paramedics who are at the scene. And if we take that on the technical side, who should you talk to for your postmortems or for your incident review? Well, obviously the first responders. Who were the engineers that responded to that outage? Who were the software developers who helped write the patch that eventually fixed things? What were their ideas, or what did they see? But oftentimes people stop there. And if we're thinking in the mind of a police unit or a police investigator, they would never just stop by talking to the other policemen around or the firefighters or the paramedics. They would also talk to the witnesses. So we obviously need to talk to the witnesses of our technical incidents as well. Who were the people that first identified this issue? Oftentimes, the person that first identified the issue with your technical systems are not the same people that actually resolved it, that worked on fixing it. So we need to think of who those people were and talk to the people who identified the problem. And then lastly, if we think of police investigators, well, they will always talk to the victims of the crime, right? You don't want to just talk to the witnesses. So if a victim is around, that will be one of the primary people that an investigator would talk to. And similarly with our technical systems, we want to talk to our affected users. Now, these may be people within your organization if your job is to support an application internally, but these could also be external customers, people who use your website but don't actually work for your company. Those people will have a very unique perspective because they're outsiders, but because they were affected in ways that they see things and may not know the underpinnings or the background information behind what's going on internally. So that perspective is very important. Now, for when we know who to talk to, what do we want to talk to them about? What do we want to gather? The what for our data collection? We want to gather their perspectives, right? In the case of people involved technically, we want to ask not only what they did, but what they thought they were doing, what they thought about a situation or about an environment, and then why they thought that. Because the why is far more important. The whys will allow us to understand the motives and allow us to understand the processes that we have. Because ultimately, the processes that we have, if we can improve those, they will improve the actions and the decisions that people make. One way that you can do this when you're talking to people trying to get their stories or understand what they thought is to have them write it down. I love this quote from Richard GUINDON that says, "Writing is nature's way of letting you know how sloppy your thinking is." Because it's very easy to explain verbally to somebody and to make logical jumps, to just sort of brush over things. But when you have to write things down step by step, or write things down in an accounting, you start to see where you're maybe missing some information. The other thing to do is when you have people write things down is you can start to include pictures. We've all heard that a picture is worth 1,000 words, but if I were to tell you that I saw a spike in CPU usage, or I saw a drop in requests per second, well, that doesn't say much. But if I take a screenshot of my dashboards, or in the case of this Datadog, we have a notebook feature that allows you to automatically copy images from your dashboard to a place where you can write about them. Well, it's really easy to see on a dashboard what I mean by a spike in CPU or a drop in requests per second. So including those images is very, very helpful. When it comes to the who and what, well, when should we collect this data? And the answer is that we want to collect it as soon as possible. There's a researcher, very old German researcher back in the 1800s that did a research of memory drop-offs. And he did all of these studies and he found that memory drops off sharply within the first 20 minutes. And it's a bit of a reverse logarithmic scale. So essentially, within that first 20 minutes, you lose most of what you're going to remember. And then it starts to plateau out about 2 days. So the difference between talking to people 2 days later and talking to them a week later or 2 weeks later, there's not going to be a whole lot of difference. All of their sharp memories are going to be gone. On the flip side, though, criminal researchers have found that the susceptibility to false memories increases in the inverse scale. So it means that the longer we wait, the more susceptible people are to remembering things incorrectly or being susceptible to having false memories. So when it comes to trying to gather this data, try to gather it as quickly as you can. And one way to do that is to get your project managers involved or your product managers involved, the people who are directing the work. If there's an outage, have them block off time, because we all naturally want to move on quickly from incidents and get back to building cool things. But when your project managers are involved, it makes it much easier to block out that time. Now, one thing that we do need to be aware of is, although we want to gather this information as quickly as possible, we have to be aware of data skew or corruption within people. And the number one way that we get the wrong data is from stress. If people have been going through a crisis and remediating that issue, well, they're still going to be stressed. So give people enough time to recover from that. If it's been an incident that lasted all night, they might be sleep deprived from staying up all night trying to figure out this issue. Or if it's a series of issues that they've been involved in, they may be experiencing burnout. So on one hand, while we want to gather this information as quickly as possible, we do need to be aware that our coworkers are humans and they have needs and they have stress in their lives. So we want to take that away from them, allow them to recover before we talk to them. Other ways, though, that we can have that data skew or that corruption of data is blame. And we talked about this a little earlier, but blameless postmortems, the notion is that if we blame people, if people are afraid that they're going to have punitive action, that they're going to take away responsibilities or even fire them for a problem, well, they're not going to admit to any of their own doings. They'll just pass that off because they don't want to get fired. So the number one way that we can improve our data is to not blame people. We are humans after all, though, and so there are a number of ways that our data can be skewed or corrupted, and biases are a huge way that that happens. Biases like anchoring, which means placing too much weight on one particular fact and ignoring other data or details. Hindsight bias is another big one. Anytime you hear somebody say, why didn't you do this, or you should have done that? Well, that's hindsight bias. It's essentially the notion that in hindsight, I can see everything that was happening and I could try to propose some alternate actions. But that person in the moment would have never done the thing or the action that they had done if they had that information. It's only in hindsight that we have that. Hindsight bias is creating an alternate reality where people had more information than they actually did. Outcome bias is another big one. Outcome bias says that good outcomes are the result of good actions and bad outcomes are the result of bad actions. We know that that's not the case because, as mentioned, I like whiskey. Well, we all know that drunk driving is a bad decision. It's a bad action. But I can go out and drink a lot of whiskey and then get into my car and drive around and not get into an accident. That doesn't mean that that lack of a bad outcome makes the decision not bad. Similarly, I can go out right now completely sober and drive around and get into an accident. And we know that that bad outcome of the accident does not mean that driving sober is a bad action. They're completely two separate things. There are a bunch of other biases that are available. Wikipedia, if you go to their article for biases, has hundreds of them. So I won't dive too deeply into this, but know that your biases can corrupt your data. So try to keep an open mind about what you're gathering. So all that said, I presented a lot of data. I want to share how we do postmortems at Datadog, because I think we do a fantastic job. As mentioned, we operate at a huge scale, so things are bound to go wrong. And thankfully, they rarely affect our customers or really get large enough to affect our customers on a big scale. But we do run postmortems for everything that we see, everything from the critical outage all the way down to minor ones, because the point is to learn. So if you want to learn the most, then you'll take every opportunity to do so. A few other notes about how we do postmortems. Well, we email them company-wide. So whenever someone writes up the postmortem, that goes out to everybody and allows everybody to see what's going on within the company, because we want to share that information. And then we also have a scheduled recurring postmortem meeting. So once a month, we go back through, we gather up all of engineering and anybody else that wants to join. And we go through all of the postmortems and all the incidents that we've had for that month. That allows us, again, to ensure that that information is shared. So we have 5 parts in the Datadog postmortem template. And the first is really a summary of what happened. And the summary really includes just a short description describing what happened at a very high level. And then we answer 4 questions along with that. And that was, what was the impact on customers? So again, keeping those work metrics or that top level business goal in mind. The second is, what was the severity of the outage? And again, we collect everything from critical outages all the way down to minor ones that maybe nobody would even know about. But again, collecting that information helps us learn. The third question that we ask is, what components were affected? So we want to know where in our systems, what was the reach of this? And then the fourth is, what ultimately resolved the outage? So again, just in summary, how did we fix this? If I look at a postmortem from a couple years ago, well, this is one that was actually a major outage. It was critical. We lost part of our web application, part of our query capacity. There was just a lot going wrong here. And so we can see, that what was a high level business that our customers here were trying to access, or customers that were trying to access us were shown a down page for the whole period of the outage. And again, mentioning that pictures are worth 1,000 words, well, we include a graph here. So we were using pingdom and we could see the latency just go through the roof. So again, that picture, it's one thing if I were to say we saw increased latency, but it's another thing to see this graph. So what was the impact on customers, that first question? Well, we noted that they were shown a down page. And thankfully, we noted also there's no data loss. What was the severity of the outage? Well, if people can't reach our service, that's a major outage for us. Well, what components were affected? So again, we have the parts of our systems that were affected, and then what ultimately resolved the issue. For this particular one, it was just bumping up to a larger instance within AWS where a lot of our systems are hosted. The second part of the template is how was it detected? So we want to make sure that we detect the issue early. And if it were to happen again, or the same scenario were to arise, that we would be able to catch it. So we asked, did we have a metric that showed the outage? Was there a monitor? Was there an automated alert that would have alerted us to it? And how long did it take for us to declare an outage? So we want to ensure that we're measuring our response times to things and that we're getting faster over time. So in the case of this outage, well, how did we detect it? Do we have a metric that showed the outage? And yes, we had many. We saw the pingdom response time earlier, but we had a number of other metrics that allowed us to see that we had an outage. And we did have some automated alerts and monitors on this metric. How long did it take for us to declare? Well, this particular one we declared as an outage within 3 minutes. And again, we want to include those images. So all of those metrics that we listed, we want to include the dashboards or the charts from them so that we can see what we're talking about. The third part of our template is how did we respond? And this is where we start to gather a lot of that human information. So we ask who was the incident owner and who else was involved. Again, thinking of we want not only those responders, but those who witnessed it and those who were affected by it. We also here want to include a Slack archive or a timeline of the events because we want to gather up that information. So if you're using a chat ops tool like Slack or HipChat or anything else, IRC, feel free, like grab that information. That's good information that you want to keep. And then we ask two very human-centered questions. We ask what went well? What were the processes that we had in place that went well? Because we want to keep doing those and promoting those actions and those processes. And then we ask what didn't go so well? Where were the parts of friction within our system? Because we want to address those and improve those for next time. So if I take a look back to our postmortem here, well, we see that the incident owner was Jeff. We see that the responders included a number of people here. We have a link to the Slack archives. We have a link to our dashboards and that notebooks feature that I mentioned earlier that allows us to incorporate our dashboards along with text. And then we have a basic timeline of events here. Now, when I mentioned that chat ops or chat tools are really helpful, it can be really easy sometimes to just, especially if you're in the same office or same area, to do what's called a war room, to get everybody into one meeting room where you can all talk about things and work together. And that does make things go a lot quicker for communications, but it's also really hard as you go back in time to try to understand what happened at any particular moment. Now, with Datadog, a lot of our engineers, particularly our SREs and our ops team, are remote. And so they can't just show up in a room. So we get on Slack because Slack's our chat ops tool of choice. The nice thing about this, though, is it automatically creates a timeline. We can see the entire transcript as people are chatting, what they're talking about, the information that they knew at the time. Makes it really easy when we go back later. We don't have to guess at what that timeline was. We can just take that transcript and save it. So I highly encourage you, especially if you have a culture in your organization that's remote friendly or that has remote people, try to do everything that you can within your chat tool because it's easy to track and you won't forget that information later. Now, I did mention that if the outage is still going on, you shouldn't try to do a postmortem. One of the other great things about chat tools is that it allows you to save information for later. So if you think of something in the midst of an outage, all you have to do is type it into your chat tool and tag it with something like postmortem. And then you can go back later and just search for that tag and find that information. So in this case, if Dan didn't get paged about an incident, but he thought he should have, just make a note of that. Didn't get paged, hashtag postmortem. Can go back later, figure out why he didn't get paged, add him to the rotation. The fourth part of our template is really the deep dive. It's where we start digging into the causes that happened. I'm not going to dive too deeply into this one because it's pretty extensive, but there are two links in case you want to. The first is our status page, which has a nice explanation at a high level or a higher level about what happened and the underlying reasons. And then the second one there is a presentation that Alexi, our CTO, actually wrote up for a meetup. So if you care to dive into it, it's a really interesting examination on how virtual machines actually operate. The fifth part of our template starts thinking about the future and asks, how do we prevent this in the future? So here, an important note is that we want to link to GitHub issues or Trello cards, or if you use Jira tickets, whatever you use to track your work to ensure that it gets done. Because as I mentioned before, it's really easy to want to just move on to building the next feature because we all want to build cool things and we don't really want to take time to analyze. But if we set up tasks and track those tasks, it helps us ensure that we're making progress. So within our what's next or how do we prevent it section, we have three major sections, and that's now, things that have to be done immediately within this sprint or an issue can occur again. We have next. Next are things that have to happen within the next sprint cycle or maybe the one after that, things that should be done fairly soon but aren't urgent. And then the third is later. Later encompasses things that might take larger coordination. For example, if there was a fundamental architecture flaw, we might need to coordinate between multiple teams to get them all to change that architecture. So all of that work and coordination will take a while, so we put that in the later section. And then we also want to save follow-up notes. We want to save an area where we can make notes about any of the actions and comment on them. If we look at our postmortem here, well, within the now section, we saw that we had to ship fixes. And so we see that not only do we have those assigned to a couple engineers, we have links to the Trello cards, we have links to that GitHub issue, and we see that looks like that was a PR, so it was done because it's checked off. We also, though, have one that comments on a monitor for TCP error rate. And we notice that there's a note here that this doesn't actually appear to apply. So again, we want to save these notes and understand what's going on, why our actions weren't taken, or understand as people dive into the actions that we've assigned, how those actually affect things. So you want to save that information. So just to recap, how do we do a postmortem? Well, we have these 5 sections. We want to ensure that we have what happened, high-level summary of what happened around our event, ensuring that we capture what the impact was on customers in that. We want to ask how it was detected. So we want to have a portion of our template devoted to ensuring that we have the right monitoring, that they're gathering the right data so that we can receive automated alerts and hopefully see these issues before they manifest. The third is how did we respond? And this is where we gather up all that human data. We want to know who was involved, who witnessed it, who was affected, and gather up not only what they did, but what they thought, why they thought what they did, what information did they have at hand. Then we want to know why did it happen. We want that deep dive that takes not only that human information, but dives deep into the technical causes so that we can understand a problem better. And then finally, our action steps grouped into now, next, and later. And we want to track all of those actions to ensure that they're getting done, no matter what sort of system tracker or task tracker we're using. We want to track all 3 of those steps. So I know that was a lot of information about the template. I have a handy template in a Google Doc that's available. Feel free to copy that, make it your own. I've got each of those sections listed out with a little bit of an explanation for each. Again, take that, copy it, and then adjust it to suit your organization. The second link there is called Post-Incident Reviews. It's by my friend Jason Hand. So it's a free O'Reilly book. Jason works at VictorOps, which is an alerting service. But you can go there, enter your information, and download a free copy of his book. And that's pretty much the end of the presentation. Happy to stick around and answer any questions. There is a questions section within the GoToWebinar console, should be off on your right. But if you go ahead and type questions there, as I see any of them come in, I'll be happy to answer them. If at any time you do think of a question and it happens to be after this, or you want to contact me directly, I am on Twitter. It's @getbisect. So feel free to reach out on Twitter if that's your preferred way, or if you think of something later. And while I'm waiting for questions, I'll go ahead and throw up this link. So in case you want to download the slides, they're available here at bit.ly/cm-postmortems. Well, I'm not seeing any questions, but again, feel free to reach out on Twitter or via email. And download the slides to get access to some of those resources. So before we wrap up, I want to say thank you again to the amazing organizers at Codemotion. They've done a fantastic job. I do know that Codemotion also, aside from their webinars, hosts a number of conferences. So I'll be at Codemotion in Amsterdam in May. They do have Rome coming up as well. And they have more conferences throughout the year. So definitely be sure to hit the Codemotion website, find an event near you to continue learning. And with that, thank you all for joining. I really appreciate you taking the time. Cheers.